Yo! My name's Leon and I make rockets for fun. Now, you might be asking yourself, what is this thing and why should I care? Answer to both those questions, it's a rocket motor. I've made many bits and bobs over the years, but this is one of the big projects I've been working on. Now, I started developing it because the price of motors doubled in 2023 for us Australians. Now, that was unacceptable. I made this guy and it costs about 10 times less to run than what you're buying off the shelf, so my wallet's pretty happy about that. A little bit on how this guy works. Now, he's a hybrid rocket motor, so we take a solid fuel, a piece of plastic like this, light it on fire, and then we spray some liquid nitrous oxide onto that fire to make an even bigger one. Once you have that big fire, all you got to do is put a hole in one end of the motor and bang, you get pushed the other way. Whoever said rocket science was that hard, eh? My next video is going to give you some basic rocket motor theory and also show you how objectively this is the greatest rocket motor ever. So make sure you like and subscribe to get that juicy nugget when it comes out. Coming back to the topic of this video, we still need to figure out just how strong the controlled explosion is down here. Now, after its initial testing, I was 99% sure of its strength, but I never got official data. I did borrow some test hardware off some friends once, but I succumbed to every man's worst nightmare that day. When it came to showtime, I couldn't get my rocket working. Putting that little shortcoming aside, we still need some data on the motor's performance, so let's map out a plan for that. Step number one is being clear on what the goal of the project is. We want to build a structure similar to this, so we can measure the thrust when the motor does that. In doing this, we can create a thrust curve that represents a fundamental way to measure a motor's performance. Let's also outline what's required of this stand. Most importantly, we need to measure force as the motor pushes against this structure. The device needs to be portable. We have to test this motor in the middle of nowhere because, as convenient as it'd be to test in the backyard, I don't really need to give the police a reason to come knocking on the door. Take my word for this next one, but the motor needs to remain upright at all times. I'll explain why in the next video that you'll see, as you've already liked this video and subscribed to the channel. Finally, we need to consider how the motor will be constrained when it's fired, because the last thing we need is a flying baseball bat to hit us in the head. Now, I know outlining this stuff seems pretty obvious, but it is critical to making sure that what you design actually does what you want. You know, you don't want to get to the end of the design and realize it doesn't actually do what I want, or it needed to do this and that. No, we don't want any of that. Now, a good analogy for this is a midlife crisis, right? You're sort of getting towards the end and you realize, oh my God, this is actually not going in the direction I wanted to at all. So you just start scrambling around and it's a mess. We don't need any messes. We're going to be clear, concise, and bang, kill it from the start. The most important of the requirements is picking the right device to measure the force of the motor. As you know, this is the entire point of the project. So let's just go ahead and order the first thing we see on eBay. It seems like when you crush or stretch this, it will read a force somehow and spit data out from these cables. Let's figure that one out later. I'm sure it's not going to bite us in the ass when it doesn't work. Next, let's worry about portability. We're taking this thing out to the country, so let's bolt it to the back of a trailer. The trailer will also give the structure some mass, so it doesn't take off when the motor's lit. Using a trailer means we have to address two more concerns. Number one, the structure has to collapse down. Two, we cannot melt the trailer because it'd be pretty stupid being able to take it up but not bring it back. Okay, let's get to drawing. Let's start with a plate. From this, we can mount a big fat bolt, which will allow the connection of the top of the load cell. Some threaded rod will then attach the motor to the bottom of the load cell. Next, the plate has to sit off the edge of the trailer, as the motor will comfortably tear it a new one. Let's add a couple of struts, as well as some brackets to mount this to the trailer chassis. Let's go back and check if all the requirements are met. Load cell, check. Trailer, awesome. Motor's upright, sweet. Finally, Is it strong enough? Probably. But just like you, I don't want to do maths to prove it. Just by looking at this design, it feels a bit sketch. This stand is staying on the ground, so we really don't care how much it weighs. Realistically, we can throw as much metal into this as needed until it looks right. Let's add some struts here and there. There's also this point at the top I don't like. If the motor doesn't fire directly into it, this rod is going to bend and twist, and over time we're going to need to replace it. Don't want to have to do that, so let's just add this plate down here. Now it looks strong enough, and better yet, the motor can't rotate and it can only move in the up and down direction. The benefit of this design is that the stand can be reused for larger motors by adding a couple more struts to the back supports. And that brings us to the conclusion of this chapter. The plan is set, so now we can pretty much build the whole thing. But before we do that, as I said before, we're going to have a little motor debrief in the next video. Once all that's covered, we're going to take this thing out to the country, fire it, see what happens. It's going to be lots of fun. Until then, peace out.